Hello and welcome back to the lab. Today on the bench we have some neat little meters from HP. These are actually 34702As with a 34740 display unit on top. So these meters actually separate, and we have a meter function and then we have a display function on top. So kind of a neat little concept here. Not 100% sure when the date range is for these meters, but we'll get them up and going. I do know there's going to be some challenges on these because we have a meter section, but then we have a second meter section because that's actually how the display gets its value. There's a 1 volt DMM in the top half, and then there's the normal 1200 volt DMM in the bottom half. Now, what's kind of cool about these is they do go up to 1200 volts. A lot of meters stop at 1000 volts. Even my higher end Keithleys and a couple of other things, they kind of peter out at 1000 volts on the input terminals. Having the additional 200 volts can be a little bit of headroom, especially when you're measuring up around 1000 volts, just in case something decides to transient and not blow the input of an expensive meter. Some of the limitations on these are we do have an auto range, I believe. I think it's 10 megohm, but I'll have to double check that. These might be manually ranging meters. We have DC, AC, and ohms function. So no milliamps, which is fine, and voltage is on this side, and current is resistance is on this side. So there's not even an internal switch. You have to move the probes when you're measuring voltage or current. If I remember correctly, these have a dot matrix LCD display, which is actually kind of cool. So would really like to see getting one up and going. The displays, we have a very nice display. We have a display that's in a little bit rougher shape, been cracked and beat up. But we will see what we can make happen and what we can get up off the ground. From what I was told, I believe this display works and this meter works, but the power switch doesn't want to stay in on this display. I'm pretty sure this display powers up, but doesn't read anything, so we probably have reference issues and things like that on this one. There is some early silicon logic that's known to be somewhat problematic in these. The 7474s have a tendency to fail out from this era, so we might be in for have to replace a couple of ICs. That shouldn't be a problem. 7474s are relatively readily available. So I'm going to quit talking. Let's get one of these open, and we'll get started on it. We'll probably tackle this display first. So when taking a look at the meter function, here's the latches that clamp the top cover down. We have the multimeter base, which is nice that we can get to it because there's a whole bunch of adjustment points that we're going to need to deal with. But this is socketed to the display section through this connector right here. So we have connector on the bottom, connector here. There is a warning about having to work clean on the meter board due to leakage paths and things like that. So we'll definitely want to hose that off with some isopropyl after we get done handling it. This should come out from these clips, I believe. Now the question is, do we need anything else to come out? Any screws holding this thing down or anything? I don't think so. Oh yeah, no, that's the front panel, which is fine. Ah, right here. Remove screw to disassemble. These are posi drive normally, but I can cheat with a Phillips. Ooh, that's pretty quick. And there it comes out. All right, cool. Excellent. So here's our main power supply, power transformer, bulk filter caps, Some 7474s. What is it? A 3 megahertz crystal? Yep, 3 megahertz crystal. The power button's oh, this is the one where the power button does latch. That's fine. Interesting heat sinks on the transistors there. Couple of custom HP chips. There's quite a bit packed in on this thing. Well, not really too much to do in here. Maybe replace these electrolytics. Definitely test the 74. I think they're not 7474s. They may be 74 LSO2s. Let me confirm that. Okay, so to attack this, I think I want to check the 7474s, which are found here and here. HP part number 1820-0596. And then I need to be careful with this board because this is all high impedance construction, Teflon inserts, things like that. So if we don't have to do anything with this board, I will be ecstatically happy. But we're going to clean this off with some isopropyl and scrub it a few times to get some stuff off of it. We are going to replace these caps for good measure in the display unit, and then I need to check and make sure a 1.6 volt reference voltage is being generated. As long as that reference voltage is being generated, then we will be able to hopefully have a display. But we'll get into it and make sure some stuff works. So first off, these caps are going to go. Okay, we have our new capacitor section in. The wire color on this cap is incorrect, but the polarity is correct. So positive is down here for this cap, positive is up top for all the other three. That can be confirmed by the solder mask. In this case, the solder mask is correct. Don't always trust the solder mask. Trust the capacitor's orientation and circuit. There is stuff, even in the tech, especially in the tech world, 200 series scope, 2000 series scopes to be specific, where some of the solder mask is incorrect and the capacitors look like they're in backwards. But if you put them in oriented to the solder mask, power supply won't work. There is a dot on the board. I don't know how well that's showing up in camera. On this particular unit, that denotes the positive side. Was the capacitor replacement necessary? Well, a couple of these capacitors started exhibiting leakage, DC leakage, and their ESR started to go a little bit high. Is this the worst one? No, that one's all right. Reading a little high off of value. This one, I think, was the one that was really bad. Yeah, that's a 1500 microvolt or microfarad capacitor measuring at 2000 microfarads. That is actually DC leakage showing up in the way this meter is reading the capacitance. So those had to go. Let's throw it on top of the meter. We'll give it a quick power on and see if we've corrected the problem. Also, make sure there's no smoke. Don't want to crack the meter getting them joined together. But we're not shorting out to anything, so we'll fire this up, see if there's no smoke, and see if we get some sanity on the display. Okay, power meter needs to come on. We're drawing about 1.4 watts with the unit off. Turn the unit on. And now we've got 9 watts, so not terrible. The display's somewhat reacting. I need to clean up the switches a little bit. Decimal point's moving. That measured something. Let's throw some voltage at it and see if it does anything different, or if we still have some troubleshooting to do. Got it hooked up to the power supply. We have the meter in 100 volt mode. And we'll turn on the supply. Nothing. So we still have a problem up in the top unit. Next up, let's check those flip-flops. So something really interesting happens when I turn the unit on specifically. It does come up and then count down real fast. So I do think we're not getting any clocking signals or anything like that. So that's going to be the next thing we're going to check, is to make sure we're actually getting timing into the TTL circuitry. Okay, so my main oscillator check is at pin 14 of U9, which is the proprietary HP meter chip. Here's pin 14. That looks like a decent clock to me, and it is clocking right at 3 megahertz where it's supposed to, according to the frequency counter, which is right there. So we at least have some clocking. Flip-flops may still be a problem, though. Okay, we're going to check U20 pin 6. That looks like it could be clock activity. Let's see if I can dial this in a bit better. All right, had to pull the old 2000 laptop back out, and 7474 found in the database. Test it, and test pass. Chip looks okay. So it is not that quad, or it is not that dual flip-flop. So we have more troubleshooting to do. One of the plans for fixing this is any IC that I have to take out to make repairs easier in the future, I'm going to put in a socket. So I have a whole bunch of sockets in stock in the lab, and this one is no exception. So I'll get our flip-flop back in here, and we will continue the troubleshooting process. Okay, well, I think we have found the faulted out chip. I had to break out the differential probe on the oscilloscope to get this figured out. The power supplies in this unit are floating, and that was causing my scope a whole bunch of heartburn. So to ease in troubleshooting, we're picking up ground off of the 5-volt rail on the ground pin on one of the TTL chips. That is not going to be a problem. And I was probing around with the hot side and just looking at differential signaling, exactly what we would use a differential probe for. This cleaned up the signal quite a bit, as I didn't have to argue with the noise that was on the isolated supplies, and was able to use a reference probe for the isolated supplies. Well, we've traced it all the way to the front of the display. Everything is switching correctly. Everything's working like it should. I'm even getting BCD data up to the display itself. The display is just not showing me anything. So I'm thinking this is a display driver chip problem, which is what we're going to test right now. I did socket the two flip-flops, but once I got the differential probe hooked up, they started flipping and flopping like they were supposed to, and I did see all the clocking that I should have. This really dug the clocking out of the 60 hertz noise that I was seeing on the supply rails as well, which is totally fine. That's more a ground reference scope problem to isolated supply problem. So the differential probes made it a lot easier to look at. Let me show you what's going on. So we have the scope up and running, and we can see we're getting some data coming out of U3 pin 11. This is our BCD data 2. And if I turn the power supply on, it changes. So BCD 2 is reacting like it's supposed to. Now, U3. U3 on BCD 2 is reacting exactly like it's supposed to. The next stop from here is U2, the display driver, and the display itself. So either we have a trace fault, but I wouldn't expect the nothing to be showing up. I think U2 on this display has gone and left the chat and is just not telling the display what to do, because I have all the clocking, I have everything that I'm supposed to have. The display is just not working. So what we're going to do is we're going to take this display and we're going to swap it with this display, because this is in much rougher shape. We're going to get this display over here, and then we'll see if we don't have switching and a working meter. Well, unfortunately, my suspected good HP display driver is not good anymore. So some of the case was cracked on this one, and when I was removing it off the board, it left some pins behind. So what I'm going to do is I'm going to put the supposed bad chip in the bad board, or in the good board, and if our behavior migrates, we'll know it's a HP chip, and then I'll have to source some components, things like that. Something that's kind of cool. The displays themselves are socketed. This is what one of those matrix displays looks like. So very neat. Was able to get these off. These are glass encapsulated packages, specifically HP parts, and were quite fragile. There was a lot of carefuling getting this apart, but that one came off. So we'll pop this bad supposed bad display driver chip in there and figure out if it's our display or not here in a moment. Okay, I've got the display unit installed. Capacitors are in. Well, we can tell because of the old capacitors. Displays put in, and in theory, if I'm not getting any display on the old unit, in theory, this display driver chip just wasn't decoding the decimals correctly. Either way, I'm now down a display driver chip. So if this works and counts, what we'll do is we'll swap the caps over and make a functioning unit. If it doesn't work and count, we will get some display units to get these meters up and running. Let's see what happens. That's counting. So still got the power supply on. Let's apply a voltage. Well, that's working like it's supposed to, which is awkward. Maybe the heat from the soldering brought the chip back. Well, in this case, let's get these caps swapped back out, and we'll get the nicer face put back on, and we'll go from there. All right, as I was putting the bottom half back together, I realized this shield was missing off of this board, so I'm not exactly sure what happened to this thing before it ended up here, but it has been gone through a few times, which is all right. We're making some progress. So I have buffed the display. Looks much nicer. There were some pretty deep scratches in it, but there were also some lighter scratches that could have come out, that did come out, which isn't bad. Okay, since we got the busted piece of plastic out, no more rattles. Everything is good. These are the locking pins. They hook in and then pull it down to mate this connector. I've got to get the securing screw back into over by the transformer, which isn't a problem. And now we flip this over, pull the tabs all the way back, which it is not, and that's why it's not seating. That goes down, and then we push the tabs in the back to pull everything together. And we have a meter again. Power button is working. So let's do some burn-in testing. Let's let this thing sit and churn. I do need to order some bipolar capacitors because there was a note on one of these that the AC was getting marginal. Pull these cal stickers off. Looks like the last time it was caled was in 92. So not too bad. We're getting into the 90s on this stuff. I have a use for this meter once it gets up and running because I do have a need for just a simple DMM to check UPS batteries and a few other things. And this, I think, will fit the bill nicely. It'll live in DC volts and pretty much watch 12-volt stuff until the end of its days. So let's do some burn-in testing. I want to put 20 volts into the front end of this thing, and we're just going to let it sit there. And we're just going to let it do some burn-in testing. The bipolar capacitors in question on the AC range are these three right here, that I will replace these with some new ones before we do the AC alignment. If those develop a little bit too much leakage, aligning the AC range will struggle. All right, it's been quite some time, and the meter's still running. Everything looks good. It draws about 10 watts when it's on, 9.7, and everything's been running fine. So before I align it, I want to get those bipolar caps in there and a couple of other things, but that's going to make me wait on the post office. So for right now, we're going to wrap this video up because the repair's done. And then let me know what you guys think in the comments, if you want to see the alignment done on this particular meter or not. We'll move forward, but I will get those caps ordered so we can get this lined up and ready to spread some small amounts of ppms, but these particular meters do have some relatively good accuracy for only being a 4-digit. So with that, I hope you guys enjoyed. As always, more is always on the way. Patreons are running about 5 videos ahead at the moment, so if you'd like to see a little bit more content, go ahead and check out the Patreon page. There is nothing behind the paywall at Patreon right now. It's just people who have decided to support the channel. Their support helps way more than anybody knows, and helps keeps the light on and the videos coming. So, if you'd like to support the channel, PayPal link or Patreon in the description below. And as always, more is always on the way, and we'll see everybody in the next video. Bye for now.